Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question for 2019 Time Zone 2 in May, question number 23, relating to the topic 17, the high level of equilibrium, introducing some calculation concepts in equilibrium. Let's see, given iodine and bromine, I2Br2, gases were mixed and allowed to reach an equilibrium. So this is the equilibrium concerning, which means if there's going to be a forward reaction, 1 mole of the N2 will reacting with 1 mole of the Br2 to form 2 moles of the IBr, right? Makes sense? Yeah. So given the initial concentration here and the equilibrium concentration, and our target is to find out the value of the equilibrium constant, simply means the Kc, right? So first of all, by definition, we realize that the Kc is defined as based on product concentration over reactant concentrations, right? So in this case, the product which is going to be the IBr concentration. But remember, this time the coefficient is set to be the power when defining the equilibrium constant. So don't forget to put a square on it. And over the concentration of I2 to the power 1 as coefficient is 1, and also Br2 as well. Right? So this is the definition, right? And the second thing the students are required to know is that these concentrations can never be the initial concentration, because according to the definition of Kc, all the concentration defined must be based on equilibrium concentrations. That means our target here, very clear the first time, is to figure out what is the value of X, right? So given that the initial and the equilibrium concentration for iodine and Br2 is to be like that, what is the information that is given is actually the change, right? Because remember from the IDs from the ICE table, or so-called the ICE, right? The I stand for the initial, the E stand for the equilibrium, and most importantly, we must be figuring out the C stand for the change. The change in this case for the iodine is that from 0.2 down to 0.1. That means I'm going to lose 0.1 unit of the concentration, right? Similarly, according to the recipe 1-to-1 ratio, you are going to do the same thing, that's deducting this 0.1, right? And this is what explains why this is all having the same modes of deducting, right? And all this way will goes to the production of the product, right? Why here comes some consumption is all because there's some forward reaction at the very first beginning, right? So that's why by having the 0.1 moles that being dismissed according to the recipe. The recipe says 1 moles of iodine and 1 moles of bromine will goes to 2 moles of the IBr. So that's why by deducting 0.1 moles, at the end I will be producing 0.2 moles according to the mole ratio 1-to-1-to-2. So that's why from 0 initial all the way plus 0.2 for X, I will be having 0.2 as well. So after achieving all the equilibrium concentrations, we confirm it because this is in the last position. Then we can simply plug in the numbers, right? So at the end, the IBr, which is of concentration of 0.2, so remember, make it square, over the equilibrium concentration, which is going to be 0.1 and also 0.1, right? Yeah, without using calculator, supposedly we can still achieve the answers. Quite simple. It's all because the only numbers that we need to think of is the factor 2 here, right? Because here we have 2 square. So 2 square is of a factor of 4, right? So even though we no need to use the calculator, or we don't know how to do those crazy decimal places moving, still okay, because the answer is going to be within a factor of 4. So that's why from the cases we can see there's only one choice with a factor of 4. So that's our answer will then be C.